Good afternoon. We'll wait a little bit to see if anybody else joins us. Nope, wrong one. Sorry. Dashboard again. All right. So last time we were looking at scientific notation right here, right? And we said that we were going to do, and by the way, here's the lecture that I told you I would be posting. So this is the scientific notation part that we needed. And then I told you I would do some more on that. And PowerPoint, I think we finished it. I want to say we did, but I'm not sure. Let me check. Okay. Here we go. All right. So far, we do not need this just yet. No, 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 no. Yeah, we were there, SIGFIG practice. And then we did this. Yeah, addition and subtraction. We did a few more. That was it. Yeah, okay. So no, we're done. Okay, we're done with this PowerPoint. That's what I thought. All right, so let's just go to the board and I will show you how to do the next rule in scientific notation, because there are different ways of looking at scientific notation. And let me get my book. Just a second. Okay, here we go. I've got it now. I just needed to look for a problem or two here that I like. Book. Okay, so we are going to do scientific notation. We're going to do the next rule and then we're going to do a mixed one. Okay, so share my whiteboard because it's easier to do it here. All right, so the rule for addition, subtraction, we know we have to always bring the lower one up, right? And then add them. But with multiplication, what you do, and I'm going to give you an example here. 12 times 10 to the 4th centimeters times 5 times 10 to the -2 meters. Centimeters again. Okay, so this is one thing, right? And this is the other. So what you do is you multiply these two and you get an answer, whatever the answer is. So 12 times 5 is 60, if I'm not mistaken. Oh no, hold on. Yeah, it is, I think. I think that's right. Shouldn't doubt myself, but I do sometimes when I look at it. Yeah, so it's 60. And then times 10 to the what? Well, we have a 4 and we have a -2. So you're really supposed to add these numbers, okay? So it's 60 times 10 to the second. And this, of course, since it is multiplication, is centimeters squared. Now, the only problem is this is incorrect scientific notation. So in order for it to be correct, the number before the decimal is here right now, right? I mean, there's an understood decimal there. Has to be between 1 and 9. So in order for that to happen, you have to move it one spot, and it needs to be here. So we are decreasing this area. Since we are decreasing this area, we need to increase this area by 1. So the answer, sorry, I ran out of space, is 6.0. And we do we need the 0.0? Well, the answer is yes, because the answer is no, sorry, because we only have one sig fig here. So we have to watch that too. And you notice the answer 60 also has 1. So 6 times, oops, I went to the eraser, times 10 to the 3rd centimeters squared is the answer for that one. Okay, let's do another one. Here's another one. We got, and I'm going to put them in parentheses, 3 times 10 to the 7th. And this one is kilometers times 3 times 10 to the 7th. Okay. So this is going to be, and the answer to this one is, remember we multiply these two, so that gives you 9, right? And then we take the 7 and add it to the other 7. And in this case, we are already in good scientific notation, so we don't need to do anything but add it. And we are also multiplying these. And when you multiply, you add exponents, and that's like saying kilometers to the 1 times kilometers to the 1. So it becomes kilometers, 1 plus 1 is 2, right? And there you go. That one was easy. Not all of them are this easy, but some of them are. All right, here's another one. I'm gonna do 2 times 10 to the negative 4. So remember, when you have negatives, you have to think about that too. Oh, and that's millimeters, sorry. I'll put my millimeters on there. Okay, times. And by the way, when you are multiplying anything, they all have to be in the correct number of sig figs. You just got to remember that. All right, so multiply these two, right? That gives me 4. And then we say we add. So it's going to be negative 4 plus negative 4. I know it's weird, but that's just how it would be, which is actually, you know, going to be equal to 4 times 10 to the negative 8, right? And that is millimeter square. And so far, oops, sorry, I was a little spot right there. Okay, so far so good. Those have been very easy because they're with each other. Okay, now that's multiplication. Let's do another one. Let's do another multiplication, a real good one. Okay, let's do one that is going to give us a really large number, like, let's say 9, oops, 9.5 times 10 to the 6. And then we're going to make it meters again. Meters is good. Times, let's say 6.8 times 10 to the negative 4. All right. And this is still meters. Okay, so you always have to have the same units when you're multiplying also, because you cannot multiply meters times centimeters. You have to convert one to the other, but we haven't learned that yet. So that's why we're not doing that. All right, so first thing to do is to multiply the 9.5, right, times the 6.8. And that's going to give us 64.6. So we're just writing this down so far. Times what? Well, it's 10 to the 6 plus -4, right? And this is meters squared. So that's going to be equal to 64.6 times 10 to the second so far, right? But we need to back it up because that is incorrect scientific notation. And also we need to watch our sig figs. So that's going to end up being 6.5, right? And then since we backed it up 1, we need to increase this by 1 times 10 to the third meters squared. And there you go. So far, you getting it? Just do a thumbs up. Okay. If you are getting it, do a thumbs up, please. All right. Or just tell me in the chat if you need anything else. Do you think you've got it enough to keep going to another one? No? Okay. All right. So, okay. Give me a thumbs up again if you want more problems in multiplication. You do. Okay. All right. I'll do one more. And we'll go once again, one by one. Move these over here. Oh, looks like, okay, there she is. I was gonna say, looks like we lost her, but now she's back. Okay. So let's do a very good thought on this one. Let me think. Let's do 8 point. You notice we're doing, I'm just doing whatever. This is just imaginary problems in my case. So we're gonna do milliliters. It's still gonna be the same thing. Times, we're gonna do another one. Let's say 7.2 times 10 to the, oops, did I forget times 10 to the something? Yes, I did. Times 10 to the 9th, let's say, okay. And 7.2 times 10 to the -2, let's say, milliliters, okay? All right, so when we multiply, we're multiplying just this part, right? That's a 7. All right, so let's multiply that and we get a number, 8.15 times 7.2. That number is 58.68. And we're just gonna leave it like it is for now, because we're not worried about the sig figs just yet. We're gonna do that at the very end, okay? All right, now, when you multiply it, right, you're gonna add these two exponents, right? So you're gonna say times 10 to the 9 plus -2, which is same as saying 9 minus 2, right? And then milliliters are going to multiply, so it's going to be milliliters squared. And this is going to be equal to 58.68 times 10 to the 7th milliliters. But so far, square. We have two things to worry about. You need a sig figs. This one only has 2. This one has 3. And we need the lowest amount. So we need to cut it down to here. So that gives us 59, right? Because this is large enough to make that go to 9. Times 10 to the 7th square milliliters. So far, that's good. But the scientific notation, sorry, not significant. The scientific notation is not correct. Why? Because we said that this number right here, before the decimal point, has to be between 1 and 9. And 59 is definitely not between 1 and 9. So what we need to do is we need to back up that, right? Since we're backing up, that means we're decreasing. We got 5.9 here. Oops, sorry, 5.9 here. And then we need to increase this one by 1. Okay. Did you get it that time? Do your thumbs up if you did. No? Oh, yes, good. All right, so we're gonna go ahead and move on to division. Division is basically the same thing, but has one more added part that you have to do a reciprocal. A reciprocal of something is, let's say a reciprocal of 5.6 times 10 to the negative 2 is going to be equal 5.6 times 10 to the second, but it's going to be over 1, right? That's what our reciprocal is. So if this number is on the bottom, it comes up the same way, but you have to change that. And you have to divide this first, but we'll clear all that. And we'll start anew with an actual problem. Okay, the first one we have is 90. Is it 90? Yeah, it's 90, which is bad. So, see, that's a bad scientific notation, but that is how they gave it to us. And this is kilograms. And this is division, remember, so we're going to divide it by 9 times 10 to the 12 liters, which is okay because we're dividing. So it's okay to do kilograms per liter. So remember, this is one thing, this is the other thing, okay? So when we divide 90 over 9, that gives us 10, right? We got that part. All right, so that's what we have to do first. We have to do the division. Then we have to say 10 to the what, okay? So 14, normally in a multiplication, it would have been 14 plus 12, but we have a division, so we have to bring this up. So it has to be the reciprocal of 12, and the reciprocal of 12 is negative 12. So when it crosses the line, you know, the line, that line, the division line, it has to come up as the opposite sign. So in this case, that's going to be, and that's going to be kilograms per liter. That's okay, because we're dividing. Division is okay. When you're multiplying, they have to be the same though. Okay. And when you're adding or subtracting also. All right, so 10 times 2, right? 10 to the 2, because it's 14 minus 12. All right, once again, this is not in correct scientific notation. So we need to decrease this one by 1, which means we increase this one by 1. And now we have to watch sig figs. 1 here, 1 here. That's actually 1 sig fig also. So we can only keep the 1 times 10 to the 3rd kilograms per liter. Okay, that's 1. We're going to do more. All right, the next one that we're going to do is 12 times 10 to the negative 4. And that is meters times 3 times 10 to the negative 4 seconds. Okay, so 12 times 3 is 36. We know that. Then times 10 to the what is negative 4 plus positive 4, right? Because we have to do the reciprocal of negative 4. Oh, I said times, I'm sorry. I meant to divide. That was my fault. Sorry about that. We needed the division sign here. I've been doing times everything all this time. I've forgotten that that's a division. Okay, divided by. Okay, so since we're dividing, like I said, no, this is incorrect. I was multiplying. See, my brain was telling me multiply. 12 divided by 3 is 4. Okay. Okay. Now, this only has 1 sig fig. This one has 2, so 4 is good. We don't have to put a 0.0. times 10 to the negative 4 plus 4. So that is 4 times 10 to the 0, or 4, period. And that is meters per second. Remember, anything 10 tends to the 0 is equal to 1. So when you're multiplying times 10 to the 0 is as if you're multiplying, as if you're multiplying times 1. Okay. All right, next one. We have one more to do and we will be done with the division part. Then we'll do mixed everything. 20 times 10 to the 5th. 15, sorry. And that is kilometers. It's going to be divided by, this time I remember division, 5 times 10 to the 11th seconds. So this is kilometers per second. All right, so we're multiplying these two. Remember, we'll multiply the numbers, divide the numbers. See, my brain's going to multiplication. That's 4, right? All right, now multiplying 10 to the 15th. Remember, it is the reciprocal of that comes up. So plus negative 11, right? And this is going to be kilometers per second. So this is already in good scientific, in good sig figs, so we'll leave it alone. And it's in good scientific notation, so we don't have to worry about that anymore. So 15 minus 11 is really what it is 4. And that's kilometers, per second. And there you go. That's how you do division. Division is actually pretty simple. You just got to remember that when you're doing that, you have to hold on. That you have to do the reciprocal. The reciprocal is important when you're doing division. Okay, so now we're going to do a mixed one where we're going to add something. Okay, so that you remember, okay, how to do that. Okay, so we're going to add 2.45 times 10 to the 14th kilograms. That's a K plus. Just to remember, just doing one more. 4 times 10 to the 12 kilograms. Okay, remember, we're bringing the low one up to this. Since we have to move it up 2, that means we have to increase 2 on this exponent. So we must decrease 2 here. So that needs to be 0.04, right? And they all have 3 sig figs, so we're good with that. Okay, and we're adding. So the other zeros are there. It doesn't really matter in this case because they're not going to be adding anything to anything. But what you do need to know is you need to move it twice, right? Because we need it to go to 14. So this is times 10 to the 14 now, because we decrease this by 2, we increase this by 2. So when we add it, we have 9. And then the rest is 14, and it is kilograms all the way. Okay, so that's your answer. Because it is correct. You don't have to switch it to anything else. Okay. You got it? Okay. That's just to remember that one. All right, now let's do one that is a mix. Let's say we have an addition and a division. Okay, so let's say we're adding 4.1 times 10 to the 6 plus, and that's, let's say centimeters, plus, I'm just making this up. So 3.2 times 10 to the, let's make it fourth centimeters divided by, let's say we're going to do 5.6 times 10 to the 9th. And we're going to make this centimeters per milliliter. So just the milliliter here, okay? Okay, so we're adding this first, obviously. You know, the order of operations dictates that we do the addition first. So in order to do this addition, we have to move this one back too, right? So that means we're going to end up with 4.1, and then that's 10. Oops, sorry. I lost my thing because I'm trying to go too high. Times 10 to the 6, right? Okay, so that's what we have. So if we have to move it 2, we gotta do 0.032 times 10 to the 6, and we add that. Okay, so we got 2, 3, 1, 4 times 10 to the 6, and that's centimeters. That's the top part. Okay, now that we have the top part, we need to check our sig figs, because every time that you switch the way that you're doing the problem, the rules change. And this is an addition. So our addition rules follow here. And there's only one after the decimal. So we need to cut it right there. So the top part is 4.1 times 10 to the 6. And this is centimeters because we're just adding, right? Divided by 5.6 times 10 to the 9th. And this is milliliters. Okay, now when we divide 4.1 over 5.6, we're going to get a 0 point something number. Okay, so let's clear this. Okay, 4.1 divided by 5.6. That gives me, and we only need 2 sig figs, so we can just cut it out. 0.732 is just 0.73. Okay, so we got that part. Now we need the math part, the 10 to the 6, remember reciprocal, so plus -9, right? And that would be centimeters over milliliters. And everything's messed up here, but we're going to finish it first. 0.73 times 10 to the -3, right? Because -9 plus 6 is -3. And then now, you notice that this is 0.73, so we need to increase it by 1. So we decrease this one by 1, okay? So the answer is going to be 7.3 times 10 to the -4. And this is centimeters per milliliter. Okay? And that's the whole answer. I'm sorry, I couldn't. Let me put it here. 7.3 times 10 to the -4. Sorry, this thing keeps growing on me. -4 centimeters per milliliter. Need to stretch it just a little bit so I can put milliliters there. There you go. All right, so there's your answer. Now, if you were to do this in a calculator, you could, but it is not going to give you a sig figs, and it's not going to give you anything else. Now, in order to do it on the calculator, you would have to put in the type of calculator that I suggest you get is a TI 30X2S, which is the easiest one to operate. 4.1, and then second EE, and then 6 plus, the next one is going to be 3.2, right? Second EE4, close it, then divided by 5.6, second EE9. And the answer I got was 0.0000737. Okay, notice the 737 because it didn't ever cut off the sig figs. So you would be off by 1 digit because you have to do this top one first, cut off the digits, then divide. That's how I would do it if you were doing it in the calculator to be correct. Otherwise, it's going to give you 7.4 down here, which is what I got on the calculator. But it is the correct answer. It's exactly 7.37 times 10 to the negative 4. But when you cut it, like I said, it's going to be 7.4. In this case, it's not. So let's clear that and do it the other way. So if you were to do the top number first, so 4.1 second EE 6 plus 3.2 second EE 4, and then hit equal, you get a big number, which is 41320. See, here's where you would have to modify this. So that's why I said the calculator doesn't help you do the sig figs, and you have to switch sig fig rules between this one and the bottom one. Once you did that, it ended up being, you notice that it ended up being the same number, 4.1. It's as if you never touched this one. And the reason it is because 3.2 is not large enough to make that go to 2. So, and you have to cut it off at the pass right there. But with the 3.2, then you get a 4 here. So you have to watch that. That's why the sig figs are important as you go. So when you have a complicated number like these, you have to do your operations in order, like your top operation, right? Then your bottom operation, do the rules for sig figs on the top. And then when you divide, do the rules for sig figs at the end. They're different rules because the top rule is addition and subtraction rule. When you do the full thing, it's division. So the top rule was how many decimals, remember, but the next rule, the second rule that we used, the division rule, is the sig figs. So that's why it gets kind of confusing for a lot of people. And the problems that we have for practice in our assignment, which I'm going to open. Hold on, let me show you. Okay, so I'm going to share my screen again, but I'm going to share a different one now. Okay, so we're going to go back to modules, and I'm going to show you what I'm talking about. Okay, so when you get to this one right here, where are you? Here we go. All right, this one right here, scientific notation assignment. It's a worksheet, and it is, okay. See how it's got the same thing we've been doing, multiplications and divisions, and this is writing it in exponential notation and in decimal form. And then you've got some mixed bags. See here you have a multiplication first and a division. Same all the way down. And then the bottom one is double multiplication first and then division. We haven't done those, so we're gonna do one of those before we get going on something else, but this is our next step. So here we go. We are going to do it again on the board, and we're going to do a double, a multiplication, division, then a double. Okay, so let me get this. It's not letting me do this. All I want is a different it's not letting me go. Nope. It sure isn't. It is not allowing me to go up. This is not good. Okay. Because normally you can just click down here and you can get a second one. Let me close it off and do it again. I mean, maybe that'll work. Okay. Nope, it's still not doing it. Why are you being like that? Nope. Nope, it's not letting me pull it up either. Why are you doing that? Ah, here we go. Got it. Okay, so next, let's do just a multiplication and then a division. Okay, so we're multiplying these two. Let's just do a simple one. 5.0 times 10 to the negative 5. And this is going to be centimeters times, right? 4.0 times 10 to the 4 centimeters. We're going to divide that by 42 times 10 to the 6. And that's going to be milliliters. I don't care. It doesn't matter what it is. Okay. So when you do that, you've got to multiply the top, right? So that's going to give you 20, right? And then times 10 to the 5th. So it's 10 to the negative 1. And this is going to be centimeter square. That's the top. You notice the rule hasn't changed. Therefore, you do not have to do sig figs right here. When the rule changes, that's when you do it. Each change of rules, you have to change the rules. Each change of operations, you have to change the sig fig rules. But right now, the rule is for addition and subtraction for one, which we don't have here, and multiplication and division. That's the other rule. So the sig figs so far are just going to be 2, right? And here we have 2. Not really, we don't have to, but that's okay. We don't care, not at this point. Now we need to divide into 42 times 10 to the 6 milliliters. Okay, so now we divide. The division is going to be 20 divided by, clear, hold on. Let's turn it on. Okay, 20 divided by 42. And that's going to give you a small number, which is 0. And we only really need 2 sig figs, so for 8. We know we don't need 2 sig figs because everybody has 2 sig figs. And that's the rule. And now times 10 to the what? Okay, so it's -1. And the bottom's 6. So the reciprocal, remember, is -6. So when you do the math, it's going to be 0.48 times 10 to the -7. But we're still not good because we need to increase this one, which means we decrease this one. So now the answer is going to be 4.8 times 10 to the -8. And that is centimeter cube square per milliliter. See? And that's that. That's how you would do one that is a mixed one with multiplication division. If we have 2 multiplications and then divide, that's another story that you have to do both separately. Okay, so let's do another one, another simple one. Let's say 6.0 times 10 to the 3rd. You know, we're just going to go ahead and leave out for now okay, let's just say centimeters. It doesn't matter. Times, let's say 3.0 times 10 to the, let's say 7th centimeters divided by, okay. We're going to do another division down here. Let's say 7.0 times 10 to the 5th centimeters times 3. Yeah, another 3 is fine. 3.0 times 10 to the, let's say -8 centimeters. Okay. All right. So the math you do first. So you do 6 times 3 is 18, right? We have 2 sig figs, but we don't care about that right now. And then we add the exponents, 3 and 7. So that's 10. That's the top one. The bottom one, we do the same. 7 times 3 is 21. And then we add the exponents, times 10 to the -3. And that's centimeters squared both times, okay? So you notice the centimeter square is going to cancel once you do your math. So 18 divided by 21 is our next step. Clear? And that gives us, and now is where the sig figs matter. All of them have 2. So you only need 2. This is 0.857, so it's 86 times 10 to the what? Okay, so you have a 10, and then you have the reciprocal of the bottom one, so +3, right? And this is no units, equals to 13 in this case. So let's just start here, 0.86 times 10 to the 13. But once again, this is not in correct scientific notation, so we need to increase, which means we decrease. So 8.6 times 10 to the 12th. And that would not be units at all, because they were both centimeters, so therefore they canceled. Right, and there's another one. Now, when you go back and you look at this video, when you're doing your homework, it should help you, because I did every single step one by one, right? So that you would know exactly what to do, including the sig fig rules and all of that. All right. Do you want me to run through another example? You remember the thumbs up? Just show me. Yes, okay. What kind? Do you want a multiplication division, an addition division, or what?
A multiplication division one?
Another one like this one, double?
Yes, ma'am.
Okay, not a problem. All right, here we go. You're the only one here, by the way.
Yeah, I realized.
We lost Briosha, right? That's who it was.
Yes,
That was
ma'am.
here. Yeah, we lost her. I think her Wi-Fi fell. Okay, so here we go. We are going to go with, I'm making these up as I go. So, okay, let's do, okay, I got one. 6.2, well, let's just make it simple. Simple is just easier for math, but it's still the same procedure. There, okay, that's the first one. And we're gonna multiply that times, let's do 5 times 10 to them. Let's do 5th, why not? Oh, and you notice I'm not putting 5.0. This is so that we have the sig figs again. All right, and then down here, you notice I'm just copying everything as it is. Okay, So when we do this one, we're going to multiply the top first, right? So 6 times 5 is 30, right? And then we add the exponent, so 10 to the 11th. Divided by, you notice I'm not worried about sig figs yet. Why? Because this is the same rule so far. So we don't have to worry about it. 7 times 4 is 28. And this is going to be times 10 to the also 11th, right? Okay, so this is going to be interesting. When we divide 30 over 28, it's going to give us 1 point something. I know that. Let's see, clear that. 30 divided by 28 is 1.07. So I'm just going to write down 1.1. Now is where we care about the sig figs. And notice I'm writing 1.1 because we had 2 sig figs, but we actually need to cut it down because all of these only have 1. So it's really just 1. So we can just clear this and say 1 right now times 10 to the what? Okay. So we have 11, and the reciprocal of that is negative 11, right? So that's going to be 1 times 10 to the 0, which is 1. Isn't that amazing?
Yes.
It ended up being a 1. And I did that on purpose. But so that you could see that the rule, look at all these numbers we did, and it ended up being 1. But the reason that is so that you can see that whenever you do the math, you have to do the top one first, the bottom one, and then divide. That's just order of operations. Okay, did you get that one pretty well?
Yes, ma'am, I did. Thank
Okay.
you.
Do you need any others?
No, ma'am.
Okay, good. So we are going to go to escape this. No, let's see. Stop this sharing. Do a new share. Go back to the well, that's that, but we don't want that either. Not right now, because that's your, that's your assignment. But I was going to show you that you can go to this website here, okay, and do the rounding and scientific notation also. And you shouldn't have any problems doing these. And that's it. We're done.
Have a good one.
Thank you, you too. Bye-bye.